So solving a trig equation actually brings together a lot of the concepts we've been talking about in Unit 8. Solving it means finding theta or finding x, as the case may be. For each value of theta that we find, we'll actually have two separate angles because of cast and the way the trig functions work. So we look at A. We have some manipulating to do before we can actually go ahead and do anything with trig related. So I'm going to take the 2, move it to the other side. So 5 sine theta equals -1 plus 3 sine theta. If we go and remove the 3 sine theta to the left, we'll get 2 sine theta equals -1. Divide both sides by 2, sine theta equals -1/2. At this point, we need to look at the calculator. So theta would be sine to the -1 of -1/2, which when we type that in, we get that theta is -30 degrees. Now, dealing with negative angles is a little bit problematic, not too much, but knowing what we know about coterminal angles, we can make this into a positive angle. So if we add 360 degrees to this, we actually get that theta would be 330 degrees. Now that's just the one angle. To find the second angle, we actually need to look at the xy axis. Our 330 degree angle would be roughly about there. I'm going to put the 30 degrees on because that's what we originally had to get there. And that's what we're going to use to find the second angle. To find the second angle, we need to look at cast rules. And to find the location of the second angle, we need to look at the step in the equation just before we got to using the calculator. Right here. What we had is that sine equal to negative. So both of our angles that we find will be in quadrants in which sine is negative. Well, in A, all trig functions are positive, so it wouldn't be in that quadrant. In S, sine is positive, so it won't be in that quadrant. So we have to have our angles in quadrants 3 and 4 labeled T and C. The calculator gave us the angle in quadrant 4, quadrant with C. So to find the angle in the third quadrant, we need to draw into that quadrant 30 degrees. And when we draw in, we always draw from the x-axis. Now to find that actual angle, we need to measure it from standard position, which would be from here, positive x-axis all the way around. And so that second angle would be 180 plus 30. Second angle would be 210 degrees. Just change slides to do B so we have some space. Same idea. We have 3 cosecant x minus 6 equals 0. We'll move the 6. Divide by 3. And at this point, we can't actually go to the calculator like we did in the last example. The calculator doesn't have a cosecant button. But what we know is that cosecant and sine are reciprocals of each other. So if cosecant of x equals 2, then sine of x equals half. Again, at this point we can go to the calculator. So x equals sine to the -1 of half. Put that into the calculator, and we get x equals 30 degrees. Putting that on the XY axis, 30 degrees would be about there. We need to look at cast again. And what we had is that sine equaled a positive. So we need to find the other quadrant in which sine is positive. That's quadrant 2, S. We need to draw a 30-degree angle into quadrant 2, and that angle is always from the x-axis. The actual size of that angle is measured from standard position, so like that. In this case, it would be 180 minus 30, so the second angle would be 150 degrees.